So the question of when does Akselos' simulation software provide the most value? Okay, so what we see is that the software is extremely valuable both in the upfront design phase of a project, but also in the post-deployment or existing infrastructure phase of an asset's lifetime. So, but the value proposition is very different, but equally compelling in both cases. In the upfront design phase, you can save a huge amount over. So this is actually a major focus in the oil and gas industry at the moment, is CapEx reduction. So what they're very interested in is lean design. There's a strong opinion in the industry that a lot of things are extremely over-designed because you have excessive safety factors, because you don't really understand what's happening or what might happen to a structure, because you've got overly conservative, simplistic models of what's happening. If you actually model things accurately, you can understand the risks much more precisely and reduce these safety factors. Still be obviously extremely safe and ensure that in any scenario that occurs, you're extremely safe, and definitely within any sort of guidelines that are provided by the industry. But if you reduce the over-design by 10%, that's a huge cost saving both in the upfront construction and also in the lifetime of the asset. As you do maintenance. If it's a leaner design, the maintenance is cheaper over the entire lifetime. So this CapEx reduction up front leads to OpEx reduction over the lifetime of the asset, just in a very natural way. So the ability to simulate these large systems in detail really naturally leads to major cost savings in that way. So that's in the upfront phase. Also in the deployment phase, obviously I've been talking about this concept of an Akselos digital twin linked to sensor data, and that is very naturally leads to major cost savings. If you can detect and react to any issues in an asset in a predictive and precise way, you can reduce downtime. You can reduce physical maintenance when people have to go out to these assets and do physical maintenance, which is extremely expensive, both because you have to shut down the production, but also any kind of physical intervention is extremely costly. So if you've got a system in place that enables greater insight based on constant sensor monitoring and constant digital twin upgrade, leading to very, very precise understanding of the implications of the current state of your asset over its 20, 30, 40-year lifetime. Over that period of time, you can save huge amounts of money, and that's exactly where we're seeing a major interest from large industry players who have lots of infrastructure. They see these costs all the time, and they're very interested in upgrading their technology to enable a much more effective maintenance and operation regime based on these technologies. In terms of modifications to a major piece of infrastructure, that happens all the time, and our software is perfectly suited to that. One of the advantages of our software compared to conventional approaches is that it's component-based, so it's very modular. If there's a change in a part of a model, you can just remove a bunch of components and replace it with different ones that take into account that change. So, and again, parameters are also a very relevant concept in that situation. So, you can modify models by just changing parameters and resolving very, very quickly. So it's extremely well suited to reconfiguration of physical assets. When you change your physical asset, or when you want to figure out what kind of change would be a good idea, it makes sense to do it to your digital twin first. Understand the impacts on reliability and so on, throughput, safety, these kinds of things. And then obviously you can model it all out first, and then you can do it to the digital twin, or you can do the reverse. Any changes that occur to the physical asset can easily be incorporated into the computational model. That's not unique to what we provide, but we facilitate it. Our software, because it's component-based, it's modular, it's parameterized, and the fact that the solves can be done extremely quickly, all that comes together to mean that it's extremely well suited to reconfiguration and resolving and reanalysis of these critical assets. And I guess I should emphasize the types of assets we talk about. We're working with power systems companies, so gas turbines, vibrations of gas turbines, wind turbines, offshore structures, oil and gas structures, ships, so marine, mining infrastructure. So a very wide range. We're looking at aerospace and automotive as well. So it's a very, very wide range of application areas where critical engineering decisions have to be made, and you need the best analysis tools to understand exactly what's happening in the design.